Hey everyone, so welcome back to my channel. So myself Raza, and in this video I am going to discuss some more bits related to the chapters polynomials, right? So already the previous video we have discussed previous year MCQs related to polynomials. So if you haven't watched, so please go through that video, right? Now let us see the first question. So a quadratic polynomial whose zeros are 5 and minus 2 is. So whenever you are having two zeros, then directly you can make use of this particular form, x square minus of alpha plus beta into x plus alpha beta. So when you substitute the values, so it is alpha and this is beta. So when you substitute x square minus of 5 minus 2 into x plus 5 into minus 2. So on simplification, what I am going to get, x square minus 3 times of x minus 10. Hence the answer is x square minus 3x minus 10. Next, if y is equal to p of x is represented by the graph, then the number of zeros are. So already we know that. So at how many points my graph is intersecting my x-axis? So that is nothing but number of zeros. Hence it is answer is 4 because it is meeting x-axis at 4 points. Next, moving on to question number 3. So if root 3 and minus root 3 are the zeros of the polynomial, so already by using the previous form, that is nothing but x square minus of alpha plus beta into x plus alpha into beta, so we can write it as x square minus of root 3 minus root 3 into x plus root 3 into minus root 3. So this I can write it as, so this root 3 minus root 3 will become 0, this total term will vanish. Hence the answer is x square minus root 3 whole square, which is nothing but 3. Hence the answer is x square minus 3. Now you can observe from this that whenever you are having two zeros which are equal in magnitude but opposite in signs, then simply what is the answer? It is nothing but x square minus, so whatever the magnitude, so that is nothing but root 3 whole square. So you can remember this form. So square and root gets cancelled, so this can be written as x square minus 3. Okay. Next, the quadratic polynomial whose zeros are root 15 and minus root 15. So already we have discussed, right? So this can be written as x square minus of root 15 whole square. So this I can write as x square minus 15. Hence the answer is x square minus 15. Next, if one zero of the quadratic polynomial is 3, if one zero is 3, then the other zero is asking, right? So whenever you are having one zero, then to find out the other zero, you can make use of sum of zeros or product of zeros. Now when you consider sum of zeros, so what we can say? So sum of zeros means nothing but, we know that it is nothing but minus of x coefficient by x square coefficient. So from this what I can say? So sum of zeros is nothing but, so alpha plus beta. Already one of the zeros is 3. So if you consider this 0 as 3, then the other 0 will be beta. So 3 plus beta is equal to minus k by 2, right? So from this we cannot come to any conclusion. We cannot come to any conclusion because beta is one of the zeros. So this is one of the unknowns and k is one of the unknowns. So from sum of zeros we cannot conclude anything. So that's why we are going with product of zeros. So what is product of zeros? So product of zeros is given by constant by x square coefficient, right? Now from this, so 3 into beta is equal to constant. So what is constant? So minus 15 by 2. Now on simplification, so in 3 table, so this cancels one time, this cancels minus 5 times. So from this the other 0 is minus 5 by 2. So here when I substitute beta value minus 5 by 2, then what I am going to get? So 3 minus 5 by 2 is equal to minus k by 2. So 3 2s are 6. So 6 minus 5, 1 by 2. So from this 1 by 2 is equal to minus k by 2. So denominator 2 gets cancelled. So from this k is equal to minus 1. Hence the answer is, so k is equal to minus 1. But what did he ask? So he asked to find out the other 0, right? So other 0 is beta, that is nothing but minus 5 by 2. So answer is minus 5 by 2. So This particular question can be asked like this also. So then here instead of other 0, so he will ask you to find out the value of k. So then k value will be minus 1, right? So k value minus 1. So that question also can be asked from this question. Next, the maximum number of zeros that a polynomial of degree 3 can have. So how many maximum zeros? So the maximum number of zeros is nothing but equal to the degree of the polynomial. So hence maximum is 3. For suppose if you ask about minimum, so minimum is nothing but 0. So if you ask about minimum, then the answer would be 0. Next, moving on to question number 7. The product and sum of the zeros. So is asking respectively. So in order we need to write it. So ax square plus bx plus c is a quadratic polynomial. Then product of zeros is nothing but constant by x square coefficient, that is nothing but c by a. Next, sum of zeros is given by minus x coefficient by x square coefficient, that is nothing but minus b by a. So c by a comma minus b by a is nothing but my answer. Next, the number of zeros of the polynomial from the graph. So from the graph we need to find out number of zeros. So this is 1 0, the second one, this is the third one. Okay, so you know the concept. So at how many points it intersects my x-axis, so that is nothing but the number of zeros. Next, the zeros of the polynomial 4x square minus 12x plus 9. So this can be done in two ways. The first one is by taking sum of zeros and product of zeros. So what is sum of zeros from this? So sum of zeros is nothing but minus x coefficient, that is nothing but minus of minus 12 by 4, which is nothing but 3. Next, product of zeros is given by constant by x coefficient, that is nothing but 9 by 4. Now from the options, so clearly since product of zeros is 9 by 4, so these two integers will not come, because when you multiply this becomes 12 and this also becomes 12, but product of zeros is 9 by 4, so clearly from these two options we can eliminate. Next, coming to sum of zeros, so sum of zeros is positive 3. So when you add these two, then you are getting negative, right? So hence we can cancel this. So finally the answer will be 3 by 2 comma 3 by 2. Now clearly you can observe, so 3 by 2 plus 3 by 2 is 3, and 3 by 2 into 3 by 2 is nothing but 9 by 4. So likewise we can proceed. Next, moving on to question number 10. If alpha comma beta are the zeros of the polynomial x square minus 5x plus 6, since this is a quadratic polynomial, so sum of zeros is given by minus x coefficient by x square coefficient, that is nothing but minus of minus 5 by x square coefficient is 1, which gives me 5. The same way, product of zeros, so alpha into beta is nothing but constant term by x square coefficient, so which gives me 6. Now from this, on substituting the values, so alpha plus beta is 5 plus minus 3 times of alpha into beta is 6. So 5 minus 3 6 is 18. So 5 minus 18 is minus 13. So it is nothing but minus 13. Hence the answer is minus 13. Next, the graph of the polynomial 2x minus 5 is a straight line which intersects the x-axis. So when it intersects x-axis, so whenever a point intersects x-axis, then its y value will be 0. Its y coordinate will be 0. So from this we can eliminate these two options. Next, so to find out the point where it meets x-axis, so simply make it equal to 0. Then what I am going to get? 2x minus 5 is equal to 0. So from this 2x is equal to 5, x is equal to 5 by 2. So the x coordinate is 5 by 2, hence the point is 5 by 2 comma 0. Next, if 1 is a 0 of the quadratic polynomial, if 1 is a 0 of the quadratic polynomial, if we consider this polynomial as p of x, then we can simply say that p of 1 is equal to 0. So when p of 1 is equal to 0, then what I can write? So 1 square plus k times of 1 minus 5 is equal to 0. So when you simplify, 1 plus k minus 5 is equal to 0. So 1 minus 5 is minus 4. So when you transpose, we get k is equal to 4. Hence the answer is k is equal to 4. Next, moving on to question number 13, and the question is a little different. The number of zeros lying between minus 2 and plus 2 of the polynomial f of x whose graph is given below. So between minus 2, so between minus 2 and plus 2. So here he is not asking the number of zeros, so he is asking in between minus 2 and plus 2 the number of zeros. Okay, so in between minus 2 and plus 2 only these two are the possible zeros, hence the answer will be 2. For suppose if we did not mention this between minus 2 and plus 2, then how many zeros will come? So these two also will include, then we will have 4 zeros, right? So for the same question, so you can have 2 changes, right? So with this we are going to have one option which is nothing but 2. So without minus 2 and plus 2 you will have 2 more zeros, that is nothing but answer will be 4. Next, if both the zeros of the quadratic polynomial ax square plus bx plus c are equal but opposite in sign. So already we have said, so if one 0 is alpha, then the other 0 is minus alpha. So whenever you are having such zeros, then what you are getting? So it is nothing but in the form of x square minus alpha square, x square minus alpha square. And in this you can observe that there is no x term. So if there is no x term, that means this second term, that is nothing but bx, should become 0. So if bx is 0, then only possibility is b is equal to 0. The only possibility for this is b is equal to 0. Next, sum and product of the zeros of the polynomial x square minus 3 are respectively. So how can you write this as x square plus 0x minus 3, x square plus 0x minus 3. Then what is sum of zeros? So sum of zeros is nothing but minus x coefficient, that is nothing but minus 0 by 1, which is nothing but 0. Next, product of zeros is given by constant term by x square coefficient, that is nothing but minus 3 by 1, which is equal to minus 3. Hence the answer is 0 comma minus 3. Next, if the zeros of the quadratic polynomial are equal in magnitude but opposite in sign. So already we have discussed that bit here. So then what we can say? Sum of its zeros is 0. So whenever you are having two zeros equal in magnitude but opposite in sign, then clearly sum of zeros is 0. Right? Next, moving on to question number 17. If one of the zeros of the quadratic polynomial ax square plus bx plus c is 0, that means, so one of the zeros is 0. So if I consider alpha is equal to 0, then he is asking you to find out what is the value of beta. So whenever you are having one of the zeros as alpha, that is 0, then you can go with sum of zeros. So sum of zeros is nothing but alpha plus beta, so which is equal to minus b by a, that is nothing but minus x coefficient by x square coefficient. Since alpha is 0, so clearly beta is equal to minus b by a, that means other 0 is minus b by a. Next, the polynomial whose zeros are minus 5 and 4. So already we know the form x square minus of minus 5 plus 4 into x plus minus 5 into plus 4. So this gives me x square minus 5 plus 4 is minus 1. So minus into minus is plus x minus 20. So x square plus x minus 20 is my answer. Next, if x minus 1 is the 0 of the polynomial, then the other 0 is. So if minus 1 is the 0 of the polynomial, so here since one of the 0 is 0, that's why we have used the concept of sum of zeros. If other than 0, if one 0 is minus 1, then we can make use of product of zeros, then you will get the answer in an easier way. So product of zeros is nothing but alpha into beta, so which is nothing but constant term by x square coefficient. Now from this, already we know alpha is minus 1, so minus 1 into beta is equal to, what is constant here? So constant is minus 8 by 1. So this minus 1 and minus gets cancelled. So beta is equal to 8. Okay, so answer is 8. If one 0 of the quadratic polynomial is 6, then the other 0 is. So here also we can make use of product of zeros. So by using product of zeros, one 0 is 6 and the other 0 will be beta. So from this, using the product of zeros, so minus 6 by 1. So which implies beta is equal to minus 1. Hence the other 0 is minus 1. Next, if alpha comma beta are the zeros of the polynomial x square plus px plus q, then a polynomial having the zeros 1 by alpha 1 by beta. So whenever the zeros are replaced with its reciprocals, then what you can simply do is, so simply replace the coefficients of x square and constant. So exchange the coefficients of x square and constant. So what is x square coefficient here? It is 1. What is constant? Q. So replace the coefficients. So then I can write it as qx square plus px plus 1. Hence the answer is qx square plus px plus 1. So this is only possible when the zeros are their reciprocals. If alpha beta are the zeros of this particular polynomial, and if you replace the zeros as 1 by alpha and 1 by beta, then simply replace the coefficients of x square and constant. Just exchange. Okay. Next, moving on to question number 22. If f of x is equal to ax square plus bx plus c has no real zeros. So no real zeros means, that means the graph would be completely above x-axis or the graph would be completely below x-axis. Now this particular question is a little high level question, right? And he has given a plus b plus c is less than 0. What is it? This particular polynomial ax square plus bx plus c has no real zeros. So if it has no real zeros, there are two possibilities for the graph. Okay, either it can be completely above the x-axis or it can be completely below the x-axis. Now here if you observe, the sum of coefficients is less than 0. So when will you get sum of coefficients? So sum of coefficients is obtained when you substitute x is equal to 1. When you substitute x is equal to 1. So that means f of 1 is given. So f of 1 is a plus b plus c. A plus b plus c. So this a plus b plus c is less than 0. That means f of 1 is less than 0. So f of 1 is less than 0 means, for suppose if this is my 1, then my graph would be like this. So this is not possible. So from the given condition, so this particular graph is possible. Now if f of 1 is 0, if f of 1 is 0, then f of 0, sorry, if f of 1 is less than 0, then f of 0 also will be less than 0. F of minus 1 also will be less than 0. Likewise, for all the values, this particular graph will be less than 0. Now for suppose, if I consider f of 0, so what I am going to get? F of 0 is nothing but, so f of 0 also will be less than 0. No? Now when I substitute x is equal to 0, so 0 plus c, it will also be less than 0. So from this what I can say? So we can remove these zeros. So c will be less than 0. Hence the answer is option C. Right? So this question is little higher level thinking question. Right? Next, moving on to question number 23. If alpha, beta, gamma are the zeros of this particular polynomial. So this particular polynomial is a cubic polynomial. Hence what is he asking? So 1 by alpha plus 1 by beta plus 1 by gamma. So first of all, write down the values of sum of zeros. So sum of zeros is given by minus b by a. Next, sum of product of zeros taken 2 at a time, alpha beta plus beta gamma plus gamma alpha is equal to c by a. Next, the same way, product of zeros is given by minus d by a. Now what is he asking you to find? So 1 by alpha plus 1 by beta plus 1 by gamma. Now on taking LCM, so what I am going to have, alpha beta gamma is the LCM. So based on that, I am going to get beta gamma plus gamma alpha plus alpha beta. Now clearly in the numerator you are having this particular part and in the denominator you are having this part. Now simply replacing the value c by a by minus d by a. Since denominators are equal, so we can write it as minus c by d. Hence the answer is minus c by d. Next, question number 24. If the product of the zeros of the polynomial is 4. So since it is a cubic polynomial, so whenever you are having a cubic polynomial, so product of zeros, so alpha into beta into gamma is equal to minus d by a. That is nothing but minus constant term by x cube coefficient. And he has given the product of zeros is 4. So 4 is equal to minus of minus 6 by a, because x cube coefficient is a here. Now on simplification, so when you exchange these places, that is nothing but doing cross multiplication. you can write a is equal to minus of minus 6 is plus 6 by 4, which is nothing but 3 by 2. Hence the answer is 3 by 2. Next, if the order of the given polynomial is 4, so what is meant by order? So order is nothing but degree. So already we have discussed. So what is meant by degree? So degree is nothing but the highest power of the given polynomial. If you observe here, we can see that x power 5 is present. So this would be my degree. So degree would be 5. But what he has given? The degree should be 4. So if you want to make the degree as 4, we need to make vanish this particular term a into x power 5. So we cannot make x is equal to 0. So only possibility is we can make the coefficient of x power 5, that is nothing but a is equal to 0. Hence the option is C. That means a should be equal to 0. Understood. Next, moving on to question number 26. If one root of the polynomial, so this is a quadratic polynomial, and already we have discussed about this concept, right? So whenever 1 0 is reciprocal of the other, so here 0. So if 1 0 is reciprocal of the other, then what we said, the shortcut is x square coefficient should be equal to constant. X square coefficient should be equal to constant. Just recall these things. What is x square coefficient here? 5. So 5 is equal to constant is k. So clearly k is equal to 5. Hence answer is done. Next, alpha beta are the zeros of this particular polynomial. So first of all, write the given quadratic polynomial in standard form. That is nothing but x square minus px minus p into 1 is p minus c. Okay, so this is nothing but my polynomial. Now since alpha beta are the zeros of the given polynomial, we can write down alpha plus beta, that is nothing but sum of zeros. It is given by minus of minus p by 1, which is equal to plus p. Product of zeros is given by constant by x square coefficient, that is nothing but minus p minus c by 1, which is nothing but minus p minus c. Now what did he ask you to find? Alpha plus 1 into beta plus 1. So we can write alpha plus 1 into beta plus 1. So this can be written as alpha into beta plus alpha into 1 is alpha plus 1 into beta is beta, 1 into 1 is 1. Now since we know these values, alpha into beta is nothing but minus p minus c plus alpha plus beta is nothing but p plus 1. Now minus p plus p we can cancel it out. So this can be written as 1 minus c. Hence the answer is 1 minus c. Next, if sum of zeros of the polynomial, so this is a cubic polynomial and he said that sum of zeros is 6. So what is sum of zeros for cubic polynomial? So sum of zeros is given by minus x square coefficient by x cube coefficient, right? So already sum of zeros is given as 6. So 6 is equal to minus x square coefficient is minus 3k by x cube coefficient is 2. Now on simplification, what I am going to get? So directly I can transpose this 6. So this becomes 12 is equal to minus of minus 3k is plus 3k. So from this k is equal to 4. Hence the answer for this question is 4. Next, if alpha, beta, gamma are the zeros of this particular cubic polynomial, then what is the value of alpha square plus beta square plus gamma square? So this is nothing but sum of squares of zeros. So already we know a square plus b square plus c square formula, or you can recall the formula of a plus b plus c whole square. A plus b plus c whole square can be written as a square plus b square plus c square plus 2 times of ab plus bc plus ca. On rearranging, so we get the value of a square plus b square plus c square. So a square plus b square plus c square can be written as a plus b plus c whole square minus 2 times of ab plus bc plus ca. So in the place of ab, bc, ca, we can replace alpha, beta, gamma. Now already we know sum of zeros of a cubic polynomial. What is sum of zeros of a cubic polynomial? It is nothing but minus b by a whole square minus 2 times of sum of product of zeros taken 2 at a time. So it is nothing but given by c by a. Now from this you can write it as b square by a square. Now since you are having a square here, you can directly make this denominator a as a square by multiplying a in the numerator as well as in the denominator. Then this becomes minus 2ac by a square. So directly we can write as b square minus 2ac by a square. Hence the answer is b square minus 2ac by a square. Right. Next, if the polynomial ax cube minus bx minus a is divisible by the polynomial g of x is equal to x square plus bx, so this is a, right? So x square plus bx plus a, then what is the value of ab? What is the value of ab? Now if you observe this, what he has said, so if f of x is a polynomial, it is exactly divisible by g of x. That means when we divide f of x with g of x, remainder will be 0. Remainder will be 0, right? Now for that, what we should do, so we need to find out the process for this question. That means we need to do the long division process. So how will you do? So since it is a cubic polynomial, so to make it, so x square plus bx plus a, so x square plus bx plus a, so with this we need to divide ax cube. So after x cube we don't have x square term, so we are going to add 0x square minus bx minus a. Now following the process, so x square need to become ax cube. So how can you make x square as ax cube? When you multiply with ax, then this becomes a times of x cube plus bx into ax is a bx square. Next, a into ax is nothing but a square x. So in the next step, so what you should do, so we need to change the signs. So based on that, these two will get cancelled, and in the next step what we are going to have, minus abx square. So here, so since I have changed the sign, so this becomes minus bx minus a square x minus a. Next, here I am having x square, here I am having minus abx square. To make x square as minus abx square, I need to multiply with minus ab. Then this becomes minus abx square followed by bx when you multiply with minus ab minus a b square x minus a b square x. Next, a when you multiply with minus ab, then I am going to get minus a square b. Now again I am going to change the signs, so this becomes plus, this also becomes plus, and this also becomes plus. Then these two terms will get cancelled. Now finally what I am left with, minus bx plus a b square x, here minus a square x plus a square b minus a. So these are nothing but the terms that are left over. Now clearly what we can say, since it is exactly divisible by the value, so f of x is exactly divisible by g of x, that means remainder should be 0. That means this particular constant should become 0, as well as this particular x coefficient should become 0. So here I am going to check this. So a square plus, so a square b minus a is equal to 0. Now from this, a square b, so from both the terms what I can take common, I can take common a, then I can write as ab minus 1 is equal to 0. Either a is equal to 0 or a into b is equal to 1. So from this what we can say, a into b is equal to 1 is my answer, right? Next, since a cannot be 0 because a is x cube quotient, a is x cube quotient, so a cannot be 0, then the only possibility we have is a into b is equal to 1. So this is also one of the higher order, so it takes time to solve, right? Next, moving on to question number 31, the product of zeros of this cubic polynomial. So to find out product of zeros of cubic polynomial, so what is the formula? So product of zeros is nothing but given by minus constant term by x cube coefficient, so which is nothing but minus of minus 6 by x cube coefficient is 1, so which gives me plus 6. Hence the answer is plus 6. Next, question number 32. A quadratic polynomial, the sum of whose zeros is 0 and one of the zeros is 3. So already we have discussed, so if one 0 is 3, Since sum of the zeros is 0, that means other 0 is minus 3. Then what is the formula? X square minus of 3 square. So which gives me x square minus 9. Hence the answer is x square minus 9. Next, if root 5 and minus root 5 are the zeros of the polynomial, so this is a cubic polynomial, so hence it will have 3 zeros. Then he is asking you to find out the third zero. So to find out the third zero, simply go with sum of zeros. So what is sum of zeros formula? So alpha plus beta plus gamma is equal to minus x square coefficient by x cube coefficient. Now from this, sum of zeros means so root 5 minus root 5 plus gamma is equal to minus x square coefficient, so minus 3 by 1. So minus 5 plus 5 gets so minus root 5 plus root 5 gets cancelled, so gamma is equal to minus 3. That means the third zero is minus 3. Next, if alpha, beta, gamma are the zeros of the given polynomial, so this is a cubic polynomial. So from this cubic polynomial you need to obtain the values of sum of zeros, sum of product of zeros taken 2 at a time, so alpha beta plus beta gamma plus gamma alpha, and the third one is alpha beta gamma. So first of all we need to obtain these values. So from this, sum of zeros is given by, so minus of minus p by 1, which is nothing but p. Next one is q by 1, which is nothing but q. Next one is minus of minus r by 1, which is nothing but minus r, plus r. Now what is he asking? So 1 by alpha beta plus 1 by beta gamma plus 1 by gamma alpha. Now multiplying with whatever the term that is missed, that is nothing but by taking LCM. So LCM will be alpha beta gamma. Then here gamma is missing, so gamma plus alpha plus beta. Now from this, clearly numerator is sum of zeros and the denominator is product of zeros. Directly substituting the values, answer will be p by r. P by r. Next, if x plus 2 is a factor of this particular quadratic polynomial, that means, so what we can say, so if I consider this particular polynomial as some f of x, that means f of, not 2, so it is f of minus 2 is equal to 0, because x plus 2 is a factor, that means x is equal to minus 2, we need to substitute. So f of minus 2 is equal to 0. That means from this what you are going to get? Minus 2 whole square plus a into minus 2 plus 2b is equal to 0. So minus 2 whole square is 4 minus 2a plus 2b is equal to 0. Now I am going to transpose this thing to right hand side. Then what I am going to have? 2a minus 2b, and taking common 2 and cancelling, then I am going to have 2 is equal to a minus b. So this is equation number 1. And here one more equation is given, a plus b is equal to 4. So below that, if I write a plus b is equal to 4, on solving this, so minus b plus b get cancelled, so 2a is equal to 6. So from this, clearly a is equal to 3. If a is equal to 3, then automatically b is equal to 1, because so if a is equal to 3, so 3 plus 1 is equal to 4. So from this, what I am going to have? So in this question a is equal to 3, and in next question he asked about b, hence b is equal to 1, right? Next, moving on to question number 37. If one zero of the given polynomial is reciprocal of the other, so once again the same question is asked, then simply what we can say? X square coefficient is equal to constant. X square coefficient is equal to constant. So from this, what is x square coefficient? X square coefficient is k square plus 4 is equal to 4 times of k, right? So from this we can write as k square minus 4k plus 4 is equal to 0. So k square minus 4k plus 4 is equal to 0 means we can write as k minus 2 whole square is equal to 0. K minus 2 whole square is equal to 0. If you expand, you are going to get this, right? So from this we can say that k minus 2 is equal to 0. So from this, k is equal to 2. Hence the answer is k is equal to 2. Next, if two zeros of this particular polynomial, cubic polynomial, is root 5 and minus root 5, then it's third zero, right? So already we know the formula, root 5 minus root 5 plus, so since we are considering sum of zeros, it is equal to minus x square coefficient, that is nothing but minus 1 by 1. So minus root 5 plus root 5 gets cancelled. So clearly gamma is equal to minus 1 is my answer. Then the third 0 is minus 1. Next, if the zeros of the polynomial are in arithmetic progression. So if they are in arithmetic progression, then we can consider the zeros as a minus d, a plus d. So whenever you are having odd number of zeros, so you can consider in this particular way. One 0 is a minus d, second one is a plus a, third one is a plus d. So common difference is d here, right? So these three zeros are in arithmetic progression. Now since we are having minus d and plus d, so directly we can take sum of zeros, then we don't have that d, right? So for that, what I am going to do is I am going to consider the sum of zeros. A minus d plus a plus d is equal to, from the question, what is sum of zeros? It is given by minus of x square coefficient. X square coefficient is minus 3p by x cube coefficient, which is nothing but 1. Now from this, minus d plus d can be cancelled. From this, what I am going to have, 3 times of a is equal to minus of minus 3p is plus 3p. So from this, a is equal to p. But what is a here? So a is one of the zeros, no? So if a is one of the zeros, that means a should satisfy the given polynomial. That means when you substitute a is equal to p, the given polynomial should become 0. That means f of p should be equal to 0. F of p should be equal to 0. So when I substitute in the place of xp, then what I am going to have, p cube minus 3p into p whole square plus q into p minus r is equal to 0. Then this becomes p cube minus 3 times of p cube plus p cube minus r is equal to 0. P cube minus 3p cube is minus 2p cube. When you transpose, this becomes plus 2p cube. So plus 2p cube is equal to p cube minus r. Hence the answer is p cube minus r. Moving on to next question. If alpha beta are the zeros of the polynomial f of x is equal to ax square plus bx plus c, then 1 by alpha square plus 1 by beta square. So from that, I can write sum of zeros as alpha plus beta is equal to minus b by a, and product of zeros is alpha into beta is equal to c by a. Now what did he ask? 1 by alpha square plus 1 by beta square. Now by taking LCM will be alpha square into beta square. Then what I am going to have, beta square plus alpha square. Now in the numerator you can see that it is in the form of a square plus b square. A square plus b square can be written as a plus b whole square minus 2 times of ab by, so in the denominator you can see that it is alpha beta whole square. Now since you can see that alpha plus beta, alpha beta are the things, already we have found those values, so we can substitute here. Then what I am going to have, minus b by a whole square minus 2 times of c by a by alpha beta means c by a whole square. Now since all the denominators we should make it as a square, so for that what I am going to do is I am going to multiply with a and divide with a to this particular c by a term, then all the denominators will become a square. So from this what I am going to have, b square minus 2ac by c square, b square minus 2ac by c square. Hence option D will be my answer, right? Next, moving on to question number 41. So what should be subtracted from the polynomial x square minus 16x plus 30 so that 15 is a zero of the resulting polynomial? Now what should be subtracted? So what should be subtracted means what is the meaning? So there will be some remainder, so which is left over, so we need to subtract that remainder. So what is he saying? So 15 is the zero of the polynomial. That means if I consider this polynomial as f of x, then f of 15 should be equal to 0. So f of 15 should be equal to 0. Then what I can say? So f of 15 So f of 15 means, so 15 whole square minus 16 into 15 plus 30. So we are going to find here. So what we are going to find? We are going to find out the remainder. So to find out remainder, simply we need to find out f of 15 only, right? So 15 square minus 16 into 15 plus 30. So 15 square means 15 into 15 only, no? So here it is 15 15s. Here we are having 16 15s plus 30. Now from 15 15s, if we remove 16 15s, that means minus 15 will be remained, right? So what we can say, 30 minus 15, which is equal to 15. So remainder is 15. So if we subtract this 15, then automatically it is divisible by 15. So then 15 will be the 0 of the given polynomial. So I think you have understood, right? So what should be subtracted means, so there will be some remainder that is left over. So we need to find out that remainder. So here we have found the remainder by remainder theorem. So already we know what is remainder theorem. So f of a, right? So we have found, so we got 15. So that extra 15 we should remove. Next, from the graph you need to find out the number of zeros. So how can you find the number of zeros? Simply by finding out the number of points where the graph is cutting my x-axis. So how many points it is cutting? So it is cutting at 2 points, hence it has 2 zeros. The same way here only it is touching, hence it has only 1 0. Next, since it is neither touching nor intersecting, so clearly it has 0 zeros. Next, moving on to question number 45. The below graph represents, if you observe this graph, so my graph is completely parallel to x-axis. That means it is a constant polynomial. Hence it is a polynomial, right? Next, the graph represents, so this graph is nothing but example for a cubic polynomial. So in our textbooks you can find this graph. So it is a cubic polynomial. Next, ax plus b, that means a into x power 1 plus b, that means it is having degree 1, hence it is a linear polynomial. Next, ax square plus bx plus c, so clearly the degree is 2, hence it is a quadratic polynomial. Next, here in these questions, so it should be given here a should not be equal to 0, here also a should not be equal to 0. Next, moving on to question number 49. The general form of a cubic polynomial. So general form of cubic polynomial is ax cube plus bx square plus cx plus d. The next question, the degree of the polynomial. So what is the degree of this polynomial? So highest power is 4, hence the degree is 4. Next, a naught x power n plus a1 x power n minus 1 plus and so on an. So here there should not be any x power n. If x power n is present also, then also the degree will be n only, right? So generally here the degree is decreasing, hence this x power n should not be, right? Next, if a is greater than 0, then the shape of the ax square plus bx plus c is equal to 0. So since it is a quadratic equation or simply quadratic polynomial, if equal to 0 is not present, then we say it as quadratic polynomial. Since he has given equal to 0, hence it is a quadratic equation. In a quadratic equation, so the shape of a quadratic equation is nothing but a parabola. So it is a parabola, and that parabola depends on the value of x square coefficient. If x square coefficient is positive, the parabola open upwards. So it is opening upwards. So hence option A will be my answer, right? Next, moving on to question number 53. If a is less than 0, then you are going to get, so downward open parabola. So we will get a parabola which opens downwards. Next, if alpha, beta, gamma are the zeros or roots of the cubic polynomial. So if it is a cubic polynomial, so we should not consider the word roots, so it should be considered as zeros. And he has considered the standard form of cubic polynomial, ax cube plus bx square plus cx plus d, right? So here the cubic polynomial what he has considered is this, right? Now he is asking you to find out the sum of zeros. So sum of zeros is nothing but given by minus b by a. Hence the answer is minus b by a. Next, sum of product of zeros taken 2 at a time. So taken 2 at a time means c by a. So answer is c by a. Next, every quadratic polynomial will have 2 zeros. So what is he saying? Every quadratic polynomial will have 2 zeros. So for suppose if you consider a quadratic polynomial ax square plus bx plus c, so it can be bifurcated into 3 types based on its discriminant, right? So if delta is greater than 0, then you can say that it has 2 real zeros. You can say that it has 2 real zeros. If delta is equal to 0, so then also you can say that it has 2 real zeros, and those zeros are equal. Next, if delta is less than 0, so what is delta here? So delta is nothing but the value of b square minus 4ac, right? So based on this, so what you are going to get? So there are no real zeros. So what we can say? No real zeros. So no real zeros means 0 zeros are present. So from this we cannot directly say. So based on the quadratic polynomial we are going to decide. So from this, what is the statement? Every quadratic polynomial will have 2 zeros. So which is a false statement. Okay. So it depends on the value of the discriminant, right? Next, moving on to question number 57. So if f of x is equal to 3x minus 2, then 0 of the polynomial. So simple question. So what we can do? So make it equal to 0, then we get a 3x is equal to 2, x is equal to 2 by 3. Hence x is equal to 2 by 3, that is nothing but 2 by 3 is nothing but 0 of this polynomial. Next, p of t is equal to t cube minus 1, then p of minus 2 is equal. If you observe here p of t, that means so whenever you are having t, on the right hand side also we are having t. Now in the place of t, what he did? He replaced minus 2. That means in the place of t, replace minus 2 on right hand side also. The same way what we are going to get? Minus 2 whole cube minus 1. So minus 2 whole cube is nothing but minus 8 minus 1, which gives me minus 9. Hence the answer is minus 9. Next, p of x is equal to x square plus 5x plus 6, then zeros of p of x is. So simply what we can say? So we can write it as x square plus 2 plus 3 into x plus 2 into 3. Now from this, how can you write this as? So this I can write as x plus 2 into x plus 3. Okay, so this is nothing but called as factorization. So based on that, what we can say? X is equal to minus 2 comma minus 3. Hence the zeros of the given polynomial are minus 2 comma minus 3. Next, p of x is equal to 4x square plus 3x minus 1, then the value of p of 1 by 4, right? So p of 1 by 4 means, so what I am going to get? In the place of x, replace with 1 by 4. So 4 times of 1 by 4 whole square plus 3 times of 1 by 4 minus 1. So which gives me 4 times of 1 by 16 plus 3 times of 1 by 4 means 3 by 4 minus 1. So this 4 which is present in the numerator will get cancelled with 16 in 4 times in the denominator. Then what I am going to have? So 1 by 4 plus 3 by 4. 1 by 4 plus 3 by 4 is 4 by 4 minus 1. So 4 by 4 is nothing but 1. So 1 minus 1 is equal to 0. Hence the answer is 0. Right? So this is all for this video. So in the next video we are going to discuss some more problems related to polynomials. Right? So thank you for watching the video. Stay connected with the channel for the further more videos. Right? So thank you.